So good morning. So I'm Bill Wagner. I work with Microsoft, primarily creating teaching materials for .Net and CSharp. The focus of this talk is going to be going open, bringing CSharp out into the wild, and how we're going to be evolving the language from this point forward. So first, just a little bit of a recap from last year of where we are and what the really big goal is for the CSharp team and for my team helping developers work with CSharp. Stack Overflow's most popular technologies. Nice. CSharp is sitting there in the 4th place. We'd like to be higher. Stack Overflow's most loved technologies. Once again, we're in this list. Interestingly, the languages above us in the most loved technologies, TypeScript is getting quite a bit of use, but a lot of them are, and Python is very popular, but a lot of the languages are very niche, very small communities. One of the things that we're really proud of, that we want to continue, is CSharp and TypeScript, which is quite a ways down, but CSharp and TypeScript are the only languages that appear on both of those lists as of the end of last year. So we're one of very few languages that are both used by a very, very large community and loved by a high percentage of that community. That's our goal and our mission, is to stay on both of those lists and hopefully to move up on both of those lists by keeping CSharp relevant, keeping it modern, and investing in it in ways that help developers build what we're building today. So here's a lot of what we're going to be going over today. So I'm going to talk about different things that we are doing to be going open with C#. Open source, open platform, open language API, cross IDE, open design, and an open mind. So that's basically our agenda. I'll take questions throughout the talk from anyone who has them. If they're on something I'll cover later, I'll defer to that point. But in general, I'm happy to take questions as we go. So let's talk about open source. The runtime for .NET is open source. The framework is open source. The compiler is open source. Our documentation is open source. Now you've seen a lot of things, whether it Build or other Microsoft events where we talk about what we're doing in GitHub. So very briefly, as far as that goes, in a lot of what we are doing with documentation, we're also trying to bring that out into the open and learn more about what people are struggling with, what developers need to know, where we're not explaining things clearly. One thing you're going to see light up this week is you've probably seen a fair amount of confusion on the terms .NET Framework, .NET Standard, .NET Core, .NET this, .NET Everywhere, and so on. We've put a lot of work into a new glossary to really define those terms very clearly, to make it very clear exactly what we mean when we say .NET Standard or .NET Framework. This is one that I'm working on right now. Anything in the docs repo, which is github.com/.net/docs, where I'm looking at a possible way of redesigning how most of the C# content is put together. So I've already got comments from a couple MVPs, from a couple members of the compiler team, from MADS, and so on. This will probably stay with this label of discussion for another month or two to get more feedback, find out exactly what people think of the idea, refine it, then we'll start to build a plan around it. So we're doing this for a lot of the things that we're looking at. Is we're going to start by opening a discussion, going, here's what we think we need to do. Here's our proposal. How do you like it? How can we refine it? What we'll do more to help others? If you go to the .NET organization, one thing I want to point out for a group here internationally is, in addition to GitHub/docs, all of our localized versions of the documentation are open source as well. So if you're a non-native English speaker, if your preferred language is something different and you find a bug in any of the translations, those are all open source as well. Happy to get PRs or issues on any of the translations. So everything we do is open source. There's also a button If you find something very quickly, if we look at the documentation under docs, like if I were to go to the tour of C#, if I were to find a bug here, if I click on the edit button, it's going to take you directly to that file in our GitHub repo. If you were to hit edit, make a change, save it, it'll submit a PR for us. So we want to make that as seamless as possible for anything that we might be doing. Cross-platform. C# runs almost everywhere. It's really kind of nice. With Xamarin, we run on iOS, we run on Android, we run on Mac. Just in case anyone's wondering, we do still run on Windows as well. If you look at Unity, one of the leading game engines, 2D, 3D game engines, massively cross-platform. C# compiler runs there. You may have seen the network go down late here Monday night, Tuesday morning here, when we shipped .NET Core 2.0 and Visual Studio. .NET Core is a lightweight platform, server cloud workloads, Linux, Mac, and yes, it does run on Windows as well. So C# is available on all those different platforms. C# everywhere. We have this one .NET concept. So this is one that still causes a lot of confusion. So who knows the difference between .NET Standard and .NET Framework? That's kind of what I thought. Okay. So very briefly, .NET Standard is a contract. Anything that says we support .NET Standard, that's a set of APIs that should run on anything that says it's .NET. .NET Framework is what we would have historically referred to as the .NET Framework. That runs on Windows, and it implements .NET Standard. Okay? .NET Core, so .NET Core 2.0 release, implements .NET Standard 2.0 and runs cross-platform. Xamarin.Android, for instance, would be an implementation of .NET Standard plus other things for Android that runs on Android. So for any of those implementations, it may and very likely does include more than .NET Standard. .NET Standard is the set of APIs guaranteed to be available on all platforms. Okay? Now, at the moment, there's a bit of an asterisk there because some of those APIs may throw not implemented exceptions. That's because we're trying to move to get to this as consistent as possible. Now, the reason this is important and the reason .NET Standard is important is for as many libraries as we can, especially NuGet packages, we want to say that your dependency is a version of .NET Standard. So then you're going to compile against .NET Standard 2.0, and that means that the binaries you create will run in an environment where anything that implements .NET Standard 2.0 is running. So if you take that library or that NuGet package, put it on Windows in a full framework app, it's going to run against .NET Framework. If you put it in a .NET Core app, it's going to run against .NET Core. But your dependency is .NET Standard. Yes?
So how long do you envisage the not implemented exception? Obviously, PCRs don't understand.
Right. Mm-hmm. I don't believe there is a timeline established for that. The way I like to explain it is we can think of 4 buckets for APIs. Okay. First, let's take an API that's all managed code. Something like systems.collections. Then that should run everywhere, so that's going to run everywhere. That's the easy bucket. Now, I'm really simplifying. Some of them aren't easy, but that's the easy bucket. There is a set of APIs that are implemented on all platforms, but their implementation is different. So let's take system.io. It works with the file system. A Windows file system is different than a Mac file system. So at some layer, that's going to be different implementations. Networking is a different one. System.networking APIs are built into the Windows OS. On Linux, we take a dependency on an OSS library to do HTTP and TCP and other networking. So the API surface is the same, the implementation is different. Now we get to the 2 really hard buckets where there's a fair amount of discussion. The first really hard bucket is Because in its original implementation, .NET Framework had some Windows-specific APIs. There isn't something like the registry on Linux. Those throw not implemented exceptions in some cases. We may try to implement something underneath it that acts like a registry for application only, don't know. But those may, for historical reasons, just continue to throw stuff. Why would they be in the standard? Because taking them out would break a lot of other code that, for historical reasons, put things in the registry. So we can fix some things, remove some of the dependency where a path goes through certain bits of code, but still has to compile against something that might not be there. The fourth path that is a little bit tricky is where it relates to reflection. Okay, so, and in this path, we have a few different interesting things coming up, keeping .NET modern. If you think of a device like a phone, in an ideal world, I don't want to JIT on my phone, right? Because that uses battery, uses memory, so on and so forth. In an ideal world, I upload packages into the store that have already been turned into executable code, compiled, and I pull down those images. That means reflection won't be available because they've already been compiled and the metadata is removed. So that's a different engineering problem to figure out. What do we really need for reflection in standard to do certain things? And what kind of things can we live without? So those last two buckets especially get hard. Okay. If you watch the Core CLR and CoreFX repos, and especially the .NET blog, when Emo talks about these problems, you get a good idea where it's going. So I don't know that there's a timeline for saying that no API in .NET Standard will ever throw not implemented exceptions. I don't know if that's even something that is feasible. Okay. But it is for historical reasons to try to be as backwards compatible as possible. Okay. Other questions on .NET Standard and where that part's going? So now you can all tell your friends and explain that difference, right? Is that clear? Cool. Okay. Going open, working with Roslyn. So Roslyn at one point was a code name for the new compiler. It's now the APIs to work with things about that. So we have syntax trees and more. The goal behind Roslyn and the C# language engine, also the VB.NET language engine, is there should need to be only one code base in the world to understand C#. So if you want to build an IDE or an editor, if you want to build linting, analysis tools, code checking, static analysis, fixes, refactorings, source generation, scripting, REPLs, maybe compiling, you should be able to use the Roslyn APIs to do that. One tree to rule them all, builds an expression tree, let's go climb it. So let's do that cross-IDE OmniSharp project. So it's an open source community project, leverages Roslyn, language services. It is used by all of these editors in order to provide IntelliSense, syntax coloring, and so on in any of those editors, all leveraging Roslyn. Open design. So language design really is a conversation. How do we want to extend the language to make it easier and to make all of you more productive using C#? What things can come next? You know, there's a discussion around this where we have things that I'll hear people in the community say, oh, geez, C#, it's already 7, it's mature. Isn't it done yet? No, we think there's some stuff that could be cool. I'll show you some of the things we're looking at for C# 8 in this talk. Get some feedback on some of those ideas. And especially having an open mind. C# started as an object-oriented language. There's a very interesting thing that we're finding right now is that, believe it or not every problem should be solved with objects. Who knew? But it's kind of in the DNA that C# started that way. So now how do we break it out of just that paradigm and make it a language we can use in a lot of different ways, in a lot of different paradigms, and yet not make it the language that has every feature in the world where you really wish stuff was missing, because then it's just hard to use. Going back briefly, C# with the open language discussion. There's a language repository, .NET/C#lang, which is where language discussion goes on. So to the extent that you want to participate, offer feedback, discuss issues in there, is if we look at the issues list, there are two really important, or actually three really important labels to look at. If we look at the discussion label, some of those will be the language design meeting notes, comment threads on any of those discussing different features. Two to stay really close with is there is a proposal label. So these are the list of features that are being proposed for language design. We got a page worth, 22 different open language design proposals. Another one that's reasonably close to that label is the proposal champion. Any of these talk about exactly what will be done and how things work. So there will be this template at the top, proposals added, and you can see this one, none of these things have been done yet. So proposal's been added, discussed in the language design meeting, decision in the language design meeting, finalized, so it's done, rejected, or inactive. If it's going to be worked on, is it spec'd? For any of the proposal champions, this issue will track how that feature is moving through the language design process. Many of those issues are going to have fairly good, lengthy discussions on them. Participate. If it's a feature you care about, if it's something you think would make the language look really bad, weigh in with your feedback. So where are we right now and where are we going? Okay, C# 7.0, it's there, use it. Who's been using C# 7.0 features? Come on, people, let's go. There's more fun stuff there. C# 7.1, our first point release, tiny features, really small. Don't be afraid of them. It's okay. It's there. It shipped, dropped Monday. I'm going to be demoing each of those features, or at least the ones that we really have code to work with. 7.2, the next point release, the features that are targeted for that release from that C# lang repo. Safe, efficient, low-level code. Think of now that Unity allows us to write cross-platform stuff with this game engine. Game developers really want to get some performance. So do some of the people doing ML or artificial intelligence or other related things. We want to be able to write low-level, very efficient code. But because we're C#, we want to write it safely. Don't want to have to drop down into C or C++ and go tracing void star pointers everywhere. We've been there. We've done that. It hurts. It's not fun. C# 7.3, maybe next steps for pattern matching. Now we're starting to get question marks. If you look once again at that C# language repo, if I go back to the issues page, and I click on the milestones, you can see things that have been set out here. 7.2 candidate, 7.x. So this might be another 7-point release. Some other major release, some other minor release, 8.0 candidates, and so on. C# 8.0, major features. So here's a theme in this. If you look at the point releases, the features that are going to be added are going to be small things that can be shipped incrementally. Major release is going to be C# 8.0. At this point in time, the thinking is that the standard and the language specification is only going to be formally updated on the major point releases. Okay, or the major releases, 7, 8, and so on. rather than go through the standards work for each point release. Doesn't mean the features won't be spec'd, just means we're not going to go through the whole formal review and standards process. So let's slide over here. Let's start looking at stuff that we can do with C# 7.1. So a lot of these kind of just tweak on some things added in C# 7. So what this application does, as part of our group working with docs, we have a meeting once a week where we triage any issues, any planned work for the documentation website. God willing, with our network, what this app does is it goes out, uses OctoKit, it's a .NET Core console application, grabs all our open issues, runs several different link queries, and gives me the list of things we do. And this is basically the agenda for our meeting. Issues that have no milestones, that means we haven't looked at them yet. We're going to look at them, figure out where they go. We have milestones based on the month. These are the things that we intend to get done in August. We're probably a little bit behind there. We do things by quarter as well to have a kind of a longer timeline of what kind of things we want to do each quarter. And then we have the backlog bucket where we look at, thankfully there's no priority 0 backlog issues, which is good. Pri 1 and Pri 2. And then anything that wasn't prioritized. Often those are going to be things that might be discussions where we're not ready to start on yet. So that's what the application does. Right now it's written in C# 7. Has using most of those features. And what I'm going to do, I'm going to now convert this slowly into adding some of those 7.1 features. One of the first ones is C# 7.1 supports async main methods for console applications. Because async in a console app is hard. The correct way to do it is what I have written here, where I'm calling this private static async task returning method. I get its awaiter, and I look at its result. Okay? It's because those are won't block the thread, so I avoid deadlocks. And it forces waiting. Code we've seen in the wild, and we've seen this question answered on Stack Overflow several times, is if I remove this and I run this app, I get a warning, and my program exited. How come? I started an async task. I didn't wait for that task to finish. My program exited. So I never executed the stuff that happens after it comes back. You can also get into deadlock situations with this. If you're doing something where you block waiting for another task to finish, that task tries to send a notification back into the first context, you can end up with deadlock. So this is something simple that programmers can get wrong. So let's make a nice, simple feature to make it easier to use. So I'm just going to remove a few lines right here. Okay, so now I have this static void main, which thankfully won't work, and I'll get to that in a second. But if you notice, I now have red squiggles on any place where I'm awaiting, because I have not turned on the 7.1 features. And the error message here says that the await operator can only be used within an async method, so on and so forth. We all know that. Okay, fine. So I'm going to go static async void. I feel bad just doing that, but I got rid of a fair amount of my squiggles, so we'll go ahead and do a build. And right now it says, program does not contain a static main suitable for an entry point. Okay, so now I've just compiled this thing, but there's no main that fits. In 7.0, that would be true. So I'm going to change this to task. I feel better already, just returning a task from an async method rather than async void. And now if I try to do a build, I still get an error. It now says, program does not contain a valid entry point. Okay, well, now we're going to have to do a little bit of actual work. So we'll right-click on our project node, go down to the Build tab, click Advanced. Now here's one important thing as we go into this world of point releases. With nothing in your CS proj, the default for this language version setting is going to be the latest major language version. In this case, C# 7.0. So if nothing's in a CS proj, the latest major version of the compiler on the machine you've installed is the version that will get used. To turn on the C# 7.1 features, I can either set it to latest, which uses the latest C# minor version on this machine, or I could specifically set it to C# 7.1. Say OK. Another new feature that came out in Visual Studio is I can now edit the CS proj without reloading and unloading and all that nonsense. What got added was this one property group condition. You see language version latest. Cool. Other versions I can set would be anything all the way back to C# 1 and any specific version that the compiler on this machine supports. 1, 2, 3, 4, 5, 6, 7, and 7.1. Now the reason for this decision, and now my squiggle should go away. The reason for this decision is if we think of CI builds, we think of building things in the cloud and containers or any of these new workloads that we're trying to do, we would like to be able to separate delivering the tools and installing new tools with the version of the language I want to use for a particular project. So now if I'm on my machine where I have 7.1, if I load an open source project and they're still on 7.0, I will get compiler errors if I accidentally sneak in a 7.1 feature. Nice. Build in the cloud, the same kind of thing. If I'm working with a particular customer that's still on 6, I can specifically set that project for that compiler version. And in my environment, even when I have the newer bits installed, the compiler will validate to that version of the language. Okay, separating between the two. It is just a setting in CS proj. While I'm using Visual Studio to show the IDE, this will work on core projects on the Mac. Just modify it in an editor, just like we do with anything else. One last bit on this feature that I do like is if I change this now to async void, which is bad. We won't do that. I do a build. I will now once again get an error that I don't have a suitable entry point. The main method now must return either a task, or if your program returns an error code, an integral error code, it can also return task event. So you can return void, int, synchronous main, task, task event, asynchronous main. Anything else will not compile. And effectively what the compiler generates is just like the code that I started with. If I go all the way back to there, it will generate a hidden main entry point, write that main.getAwaiter, so on and so forth. So that's our first fun feature, async main. Oops, we need that first bracket. There we go. Okay. Second interesting fun feature is a couple worthwhile changes involving the default keyword. If I take this method right here, which displays the issues, where I'm going to do a few other changes to it as well. If you see the second parameter there, I've got a header string I want to print out. If I don't specify anything, I say it's default of string. Basically the null string. It seems redundant to give the name twice, so let's just remove that, and it just equals default. In places where default of t, the type can be inferred, string header equals default works very nicely. One place where I really, really like this feature is that for a few very interesting reasons, we can't assign var to a lambda, or we can't declare lambdas using the var keyword. If I were to try to change this from func of issue bool to say var, okay, at that point it doesn't compile because it can't figure out what it is, because lambdas don't have type information. So I don't know what to make it. Well, if I have not declared it yet, if I were to separate it out for whatever reason, and I wanted to initialize this, this whole default of issue, of func of issue, comma bool. That's kind of an ugly expression. I've got the type on both sides, doesn't really add anything. So we'll just say equals default. Cool. So in any place where the type can be inferred, default keyword can be used instead of default expression with a type inside it. The third real interesting little tidbit that we're trying to add, or that we've added, is if I go back down to this display issues, you can see I'm passing in that lambda. I'm now going to run a link query. And in my select, I'm creating a tuple, which is a new 7.0 feature. So this tuple where you see I have number colon issue.number, title colon issue.title, so on, that's just a tuple. Think of that as a very, very lightweight type that carries across bits of data. It has 3 fields, named number, title, and author, which are number and 2 strings, integer and 2 strings. Now for what the compiler does with tuples that is magic is, with tuples in general, the field names, the type that's used, system.value tuple, has field names item 1, item 2, item 3, and so on and so forth. Those names don't have a lot of semantics. By specifying them here, I've given them those names in C# 7.0. In C# 7.1, if the field name can be inferred, I can remove that declaration, and this will give me field names, number, title, and author, which you can see that I'm using here when I print the message out. Okay? If I switch back to C# 7.0, the field names would be item 1, item 2, and author. So again, a small little feature designed to mean that we have a little bit less code to work with, a little bit less to have to type, especially repeated things to have to type. Question on that? There we go. And that shipped, all those features shipped earlier this week. Makes C# 7 a little bit nicer. Okay? Questions on any of those? Those are the major features that came out in C# 7.1. The big key that we want to talk to you on any of those is in 7.1, tiny point release. It will be turned off by default. You will have to turn it on by adding that lang version element inside your CS proj file. And it will be on only for those projects. So now let's look at some of the bigger ideas that are coming for, or planned for C# 8. At this point, what we have to say is none of these may happen. They're all in discussion. These look like likely candidates. But this is not saying that these are the features. The first one is async streams and disposables. They deal with 2 particularly thorny problems in asynchronous programming. The first one here is that if I am grabbing things out of a database, get people async, I now have this async enumerable. I can await it, do things with those people. Inside that loop, it may actually do another await as it reads further in the stream. Right? If we think of either reading from a file, I might read the first 1,000 bytes, and I want to have to await for more network traffic or for more file reading to get more things out. This is kind of ugly code in current async. I have to do async, read a block, fill a block, deal with it, make another async call, and so on and so forth. Generates some very thorny stuff. So async stream, hopefully we can be able to await each element if they're handed to us, or await blocks of elements. Async disposable. This is the other really interesting problem. If I write an async method, if I write a task returning method that does async work, and sometimes in that method I allocate a disposable resource, when do you dispose of it? It can be easy to write code that accidentally disposes of the resource before you're done using it, because you've hit an await, you return from a method, you exit a using block, so stuff gets disposed, the await or task finishes, you go back into the method, and you're using a disposed object. That's bad. That's not good. So let's introduce this async disposable interface. So now I'm going to await doing something. I'm going to do a bunch of stuff inside there. I can await anywhere inside this that I want, and it will only get disposed when I'm done with the block that I'm awaiting on the outside that using await, adding that new keyword there, which says don't dispose of this thing until all of this stuff is done. Right? Simplifying that resource management for async programming. Okay, I'm seeing some very thoughtful looks here. People have had this bug, haven't you? Yeah. Hopefully making that easier. The idea of extension everything. So let's look at what this code is trying to do. And this is code written as a demo of what the language features would be. We believe that the typical use of this kind of construct is going to be where we're not adding that many methods. Here I might use typical normal inheritance, but where you might just want one or two things to add to a class, to make a new class. So here, the idea behind what is designed here is we have a person class, and we are going to extend it by making an enrollee in a class. An enrollee has one new property, which is the supervisor, which is a professor. But other than that, it has all the behavior of a person. Okay. And we're going to do it all with extension everythings. So first, we're going to make a static field, just normal static field. We know how to do that. Person, professor, we've got a dictionary, people to professors. Now, let's look at the instance constructor. This is an enrollee constructor. But notice that it says person, but it's got an extra field on it. It's going to call one of the person constructors, and then it's going to also call an instance method to enroll and set the supervisor. So if you look at enroll, this is a static instance method that is an extension. You see we have the extension keyword on the class definition. Enroll, we're going to use that static field to set this extra property. We can retrieve that property from that static collection, and we have the static property to get all of the students, which is every single one of the enrollees. So we've built this whole new class, not by building a class, but just by using extension methods, because we can now have more extension everything. This one is my favorite one. Quick show of hands, who does anything with JSON type data? Some of you are lying because I didn't see every hand up. Here's the idea. As we move more and more toward this world where programs are broken up in microservices, I'm sorry, I did have to use that buzzword, or broken into other different services that talk to each other, we move further away from that idea of object-oriented programming. Object-oriented programming, we said objects have properties and all the methods and transforms that work on them, and they travel together as an object. That doesn't quite work in this service-oriented transferring data back and forth between machines mode so well. So now we separate data and the functions that work on them for at some of these endpoints. So we find ourselves building types that don't have any behavior. They simply store data. One way they simply store data, we've used tuples. We can make simple classes, getters and setters, or just get and instance and so on and so forth. Let's make it really easy. That declares a person, and it is a person that has two fields, a first and a last, typically their names. What the compiler will generate for this class definition is something that looks like this. Okay, so we built a class person, implements IEquatable of person. We've got two public get-only fields. We've got a constructor that sets those get-only fields. We've got deconstruction, so we can pull out just the first or the last, or deconstruct it into a tuple, or deconstruct it into two variables, and so on and so forth. We've got an equals. We've got an override of equals, and we've got an override of get hash code, where we're going to wave our hands and say it's this great hash function that the compiler will generate for us that we don't have to. Okay. And that's the idea of what we will build for a record type. You get to type this, and you get that. All of that. Sound like a big win? What's that? Sounds like F#. One may think that the F# and C# teams do talk to each other about things like that. And I think here gets to one of the comments that I made earlier that I think is really important about how this is going to evolve. F# is a functional language that works in .NET, so it can kind of use some object-oriented stuff now and then to deal with the framework. But F#'s syntax and the way you program in F# is primarily functional. C# sits at the other end of the table. It's primarily object-oriented. That's how it started. That's what it was in the beginning. It does some things in a functional way now and then. LINQ being a good example, reactive extensions, things like record types, pattern matching are starting to come into the language. But it probably will never be the functional language F# is. F# is great as a functional language. But I still hate creating all those types to do deserialization stuff, so this is cool. Okay, so open for business. A little bit of the final sections on some of the things that we're doing in terms of where we're going with different directions. That was a look at C#8 and so on. Now, we get to a lot of the resources and things that are coming up. Language strategy. We have a couple different blogs there on what is the .NET framework or .NET managed language team's strategy in terms of where does F# go, where does C# go, where does VB.NET go. All three have strong futures. F# is used as a very functional language, has some very key constituencies in analytical programming, be it financial, other areas. C# is meant to be a very powerful general purpose language. VB.NET is a very powerful general purpose language. A little bit different community, more built on productivity, so on. C# design, as I mentioned, there's the github.com .NET C# language. Blogs.msdn, this was from March, new features in C#7. It's also now covered under docs. Our docs repos, github.com .NET/docs. Ask us questions, participate there as well. Help us build things that make it easier for you to be more productive. A couple I have grayed out because they're not turned on just yet, but they're going to go live shortly. One thing we've learned, when we started the docs project, the repo wasn't really large repo. It was the stuff that we'd written. When we added all the different versions of all the different .NET frameworks, clone can take a while. Clone can take a long while on a network like here at the hotel. So we're going to split out the API docs into a different reference. The Roslyn API docs, we're starting to toy with the idea of how do we manage docs for all the different NuGet packages. So we're probably going to end up with more repos there as well. And then, of course, github.com/net/Roslyn. That's where the compiler lives. Some of the things to see from the future there. This is one of exploring what C# does internally. Let's make this a little bit larger. Let's see, there we go. Is that a reasonably good, there we go. Sharp.io allows you to type any code or copy or paste any code in the left-hand side of that window. And in the right-hand side, using Roslyn, you can take a look at what it will generate in C#, in VB, what the JIT will do for actual assembly. You can see the syntax tree, and you can see it for either debug or release builds. So if you're ever very curious about what different constructs set up, this is one good way to do it. Final thing I want to show that in terms of putting these together, I took this demo app, and remember, this is fairly small. This is, 80 lines of code. And if I go back into my property page here, first I'm just going to turn this back to C#7 and point out a couple of the errors there. And there we go. Come on, draw. Start getting all our squiggles for any place that I added one of the new features. The one I did want to point out is here where I have the tuples. The field names now, if you notice, number and title no longer have semantic names. The only way I could refer to those is as item 1 or item 2. Don't know why I'm not seeing those as there we go. But in terms of how far C# has evolved, just because it can be, every once in a while it's fun to see. If I went back to C#1, there's almost not a line in here that doesn't make use of something that's been added. Other than our using statements, any of my awaits, any of the link stuff, any of the generics. It's been a pretty long, fun trip so far. var, so on. Language has grown quite a bit over the years. Final little bit, you can reach me on Twitter at Bill Wagner. I have updated both Effective C# and More Effective C#. Effective C# was published in March, so it was certainly available. The publication date for More Effective C# is in August. So if it is not available today, it will be very, very shortly. Effective C#, I reorganized all 100 items around different themes. Release-wise, Effective C# covers up through 6. More Effective covers 1 through 7 on different themes. The places you'll find me is I will be at an Ask Me Anything this afternoon at 1:30 or 1:40 with Bart DeSmit and Richard Campbell, which is always fun. Any other questions on anything C# related? Yes?
One more question. When you changed the C# version, that seemed very build configuration specific. So when you pull up the CS protocol, it was configuration debug set.
Yes.
It
Why?
feels like that's going to cause lots of problems when you put it on the CI server and do a release build. What's the reason behind having it configuration specific?
I believe that is primarily based on how CSproj parses it. I think a typical use is going to be to set it for all configurations, because I agree, I cannot come up with any reason why you would do it. Right. Right. But even when you do that, now it writes the property group twice, or for as many different configurations as you have. I think that is based on how it's set up. I am going to, and it might be just visual. Actually, let's just try this. This may be a Visual Studio thing. Let's just try this. Let's just change this to latest. Because I'm pretty sure I've done this on core, where I put it in there. So it's just in the property group for everything. If I look here, I'm not getting any errors. Yeah, it's just... That's a Visual Studio IDE thing. So I don't have to put it there. That's just what the that's what Visual Studio's IDE editor generates. So that was a great question. You can put it there. I will also, I think I kind of glossed over this, that flag in CS Proj runs on Mac and Linux. And if you're on Mac, Visual Studio for Mac obeys this flag but doesn't have a UI to set it. Any other questions? Yes?
You said the C# language spec, you were aiming to release it with the major point releases, like the major releases.
Right.
Is there a plan for it moving out of draft for C#?
I missed the last part. Is there a plan?
Isn't the C# language spec still in draft?
Yes.
Is there a time frame when that's going to get released as an official spec?
Yes. I will give you the order of the tasks. So if you look here once again, the labels here give a hint to a couple things. If you notice, 1 and 2 are labeled ISO 1 and ISO 2. Those were official ISO standards. That effort lapsed for a while. And for a period of time, the ECMA C# Standardization Committee has been working on taking everything from 3, 4, and 5, applying it to ISO 2, and getting a standard for C# 5. Okay. That work was taking priority over moving beyond drafts 4, 6, and 7. Because understandably, MADS and a few other people that work on the spec are in the standards committee as well. Which I am a member of, by the way. So the C# 5 official ECMA standard is getting very, very close. So the order of things that we are going to do is send out the 5 standard, take the 6 draft, which was based on the Microsoft version of C# 5, find the changes to that, apply it to the standard 5 and make standard 6, and so on and so forth. So the reality is we do have some spec debt to pay off. So beyond getting 5 done, which is soon, I don't have a date for the other things. Some of it will probably happen in the open. In the C# lang repo, one of the things that is, I thought I had the, there we go. In the C# language repo, one of the directories there is, am I in the wrong repo? Yes, I am. There we go. In the C# language repo, one of the folders is for the spec, and that is the C# 6 draft. We are pulling that into Docs, so it's also published on Docs. We'll be doing the same with every update that comes out. Okay? Any other questions? Thank you very much for your time. Hope you enjoyed it, and I'll be around for lunch if you want to chat, and upstairs after lunch. Thank you.